But thanks to everyone for coming. Susan Jo Russell is from Turk, and her work has been going on for quite a while, and it involves early algebra. And I know some of you are specifically interested in that. Those of you I know just from our work in Fall River. So I know from our perspective down here, we've always had a high regard for the work you guys do at Turk and early algebra, your group, David Carrifer's group, and so forth. So we really look forward to what you have to tell us today about the work you're doing.
Thanks. So I actually wanted to just start by finding out who's in the room and what you do. So if people could just introduce themselves really briefly, that would help me know kind of who's here and what your interests might be. So, do you want to say?
My name is Pat Kolakowski. I'm a math coach. I'm a retired teacher, so I'm a math coach part-time. But I worked with Maria and Jim in the early algebra stuff in Fall River, and that's why I was interested.
I'm Gail Sellersby. I'm a second grade teacher in Fall River, and I also participated with Jim in early algebra.
My name is Arden Brooks, and I'm a research associate at the Kaput Center.
I'm Maria Glenn. I'm a faculty at UMass Dartmouth and do research in early algebra.
My name is Eddie Henderson. I'm part of the Teach South Coast cohort, and I teach in the Resiliency Preparatory School in Fall River. I teach algebra.
Is that, what level
It's
is
an
that?
alternative high school.
High school?
My name is Sarah Dalton, and I also work here at the center.
My name is James Burke. I'm a research associate here at the center and a software developer.
Becky Minnie, I'm project manager and research associate here at the center.
And I'll just say a very small bit about myself, just so you know. So I'm Susan Jo Russell. I've been at Turk, which is a nonprofit group in Cambridge, Mass. that works in math and science education. And I'm actually now the person who's been there the longest. I've been there about 25 years. Yeah. So, and before that I was a classroom teacher and what we then called staff developers and now tend to be called math coaches in a number of different schools, including Philadelphia Public Schools and Cambridge Public Schools. And I've been working largely in the area of developing curriculum for elementary students and professional development materials for teachers. And so today I'm going to tell you a little bit about the algebra work that myself and my colleagues are engaged in, which is focused on grades K to 8. And hopefully then, I wanted to have this be somewhat participatory, not just a lecture. So then we're going to just do a little math problem together as kind of an illustration. And then look at a part of a case written by a teacher. We use cases a lot in our work and a lot of collaboration with teachers doing research in their own classrooms. So that's my plan. And so instead of saving time for questions at the end, I think except for maybe this first 10 minutes, it'll just kind of be interactive and feel free to interrupt and ask questions. So we got interested in work on early algebra through the work on student curriculum and also through the work on professional development. So this is the name of our current project that's funded by the National Science Foundation. These are the people who are working on it. You can see it's a collaboration also among institutions here at UBC, which is another nonprofit group, and Summer Math for Teachers at Mount Holyoke. And those are our participants right now. We started in kind of the middle of last year, so we're kind of coming up on about a year of work on what's a 5-year project. So we're at the beginning. As I mentioned, our previous work is both the work on student curriculum, on investigations in number, data, and space, which is a K-5 mathematics curriculum, the second edition of which came out about a year ago, and the Developing Mathematical Ideas Professional Development Curriculum, which is for teachers in grades K through 8, and those are the two new modules that focus on early algebra. So that's kind of where the work started. Our work in early algebra, and so when I'm saying our all this time, it's me and Deborah Shifter and Virginia Bastable are kind of the main people here. But others have participated as well. We kind of carved out some space for ourselves, and we weren't going to take on all of what one might take on, but the two areas we decided really had potential in the early grades were the areas of generalized arithmetic and the area of patterns, functions, and change. And I'm only going to talk about the generalized arithmetic work today, and that's what this Foundations of Early Algebra project focuses on. So when we talk about generalized arithmetic, we're thinking about a generalization as a general claim that you can make about the way numbers or operations work. And what happened as we were working with lots of teachers and classrooms in a lot of different places is we began to notice, and the teachers began to notice, that these ideas about underlying general claims arose naturally as students did their kind of core work in arithmetic. So here's an example. So here's Leah, who's a grade 1 student, and this will be a familiar sort of problem. Erica bought 7 cupcakes, and Ivana bought 6 cupcakes. How many did they buy? And if you've taught younger grades, this will also be a familiar kind of response. And if you've taught younger grades, you can read it. I know that 7 plus 7 equals 14, so take away 1 away from the 7, so it is 13. So this is a kind of strategy that's very familiar. But the questions we started asking were, so what underlies the reasoning that Leah is doing? What does she understand when she reasons in this way? Would this reasoning work? Does she think this reasoning would work for other numbers? What other numbers does she think it would work for? Does she think it only works for doubles, like 7 plus 7? Does she think it works for other whole numbers? Is it possible for a young child to go beyond these specific problems and examples to talk about why that must be true? So, for example, so this is Leah's idea. I know this fact 7 plus 7, so I can reason from that to the sum of 7 plus 6. Now I'm not claiming now that Leah has this idea, but we could say that a general idea based on Leah's idea might be that in an addition problem, if an addend is decreased by 1, the sum is decreased by 1. And if we wanted to, we could write that in symbolic language as well. If a plus b equals c, then a plus b minus 1 equals c minus 1. So we started noticing lots of these kinds of ideas that were arising in the course of students' work, and sometimes students were noticing them as well and starting to articulate them. And I'll just note that if you look back in the 2000 NCTM standards, which I still find to be a really helpful document, and I wish people were still paying more attention to it, that you'll see that in the pre-K to 2 algebra strand, there's text here about illustrating general principles and properties of operations such as commutativity using specific numbers. And in the grades 3-5 algebra strand, there's text about making and explaining generalizations that seem to always work in particular situations. But I'm going to tell you just a little bit more about the themes and issues and questions we have in our research and in our project. But before I do that, I wanted you to just kind of see live an example of the kind of thing that we see coming up in classrooms. So this is a second grade class that you're just going to see some little clips about. And they do a routine called today's number, where there's a number of the day and you come up with expressions that are equivalent to that number. And in this particular case, the teacher has asked them, the number of the day is 25, and the teacher has asked them to come up with expressions with 2 addends that equal 25. Now, she actually has an agenda here. the ideas about the community